Hello. We're going to introduce some problems from the Belgian Mathematical Olympiad. It was held this Wednesday, 2nd of April, and it's called OMB, standing for the Mathematical Olympiad for the middle schools in the French-speaking regions of Belgium. Um, there are several levels. There are three levels for this OMB competition. And today I'm going to introduce the finals for the mini level. So mini level is a junior level. Um, the students from the first year and the second year of the middle school are allowed to attend the mini level. Right. I briefly translate the French problem into English by Google Translator, and I hope it's clear for my audience. The first question is something about the areas. So it states that this is the figure, this is the plan of a castle and a moat around this castle. Actually, the castle has a shape like a rectangle, 20 meters by 25 meters, and the width of the moat is 4 meters. The question is asking what the surface of this moat. This one is not so challenging, especially if you realize that is something about a round corner. Actually, it's a round corner rectangle. To calculate this area, we can just split the round corners off, or just cut them off. And as a result, we have 4 rectangles and we have 4 pieces of a quarter of a circle, right? So since the moat is 4 meters width, so actually the radius of the circle is 4 meters, and the 4 rectangles have the dimension of 25 by 4 or 20 by 4. So the area is quite easy to calculate. We have 4 pieces or quarter of circles, so the whole circle's area is pi times square of 4 and plus 2 times of 25 times 4. So that are the 2 rectangles in the horizontal at the top and the bottom, or plus 2 times of 20 times 4. That is area of the 2 rectangles on the left and the right. Yeah. Second question about some numbers or arithmetics, right? So it states that there are 10 different numbers, 10 different natural numbers. There are 2 conditions. The first condition is that the average of the 6 smallest number equal to 5. Second condition says the average of the 6 largest number equal to 11. Because it's an average, right? And we know the number, they are all 6, meaning that we can say, okay, the sum, if we calculate the sum of the 6 smallest number will be 5 times 6, yeah, average times the number of numbers gives us 30. The sum of the 6 largest number will be 11 times 6 gives us 66. The first question is about what will be the smallest of these numbers. Is it could be equal to 2, or is it possible to be 3? So if we start with 2, we can just write the smallest combination with 2, because they have to be distinct numbers, right? If we start with 2, so 2, 3, 4, 5, 6, 7, and we can use the Gaussian summation, right? You see, using the Gaussian summation, and easy to see, okay, the sum of them, the sum of the 6 numbers will be 27. So which is smaller than 30. So that's possible. That's possible. And we have to show an example, of course. If you say it's possible, just show me an example. And then we have the three numbers to be added. We can add each to the three bigger numbers. So we start with 2, 3, 4, 6, 7, 8. So the first six numbers is meeting the first condition. Their average is actually 5, right? And we still need to fill four larger numbers and to see if the four larger numbers can meet the second condition. So second condition is that the sixth largest number, the sum will be 66. And we have already 7 and 8, so it makes 15. So all the sum of the four large numbers will be 66 minus 15, give us 51. Yeah, 51. And that's really possible. You can just show an example like 9, 10, 11. The sum of the three numbers like 30. So the last one be 21. Yeah, it's 21. So that is a complete proof that A is quite possible that the smallest of the 10 natural numbers be equal to 2. Second question, would it be 3? Is it possible? So if we start with 3, the smallest possible combination will be 3, 4, 5, 6, 7, and then 8, right? That's the smallest possible. And we also sum them up. Sum them up will be by Gaussian summation again. So each pair is 11. So 11 times 3 gives us already 33, which is bigger than 30. So the first condition cannot be met. The first condition cannot be met. That means B is not possible. All right. Okay, third question. Kind of geometry, but it's quite simple about angles. Nothing to do with triangle similarities, nothing to do with congruence of triangles, squares, circles, or, okay, it states that the angle C is 70 degrees, and there are three segments which have the same length, BD, DE, and AE, right? And it is asking what is the degree, what is the size of the angle AFB. Yeah. For this question, we wanted to find AFB. So AFB is actually the same as DFE. Yeah, DFE. If we know this angle and this angle, so in the angle DEF, then we know the angle with question mark is a supplementary angle of angle E and D. So we just mark it as angle 1 and angle 2. And we know due to the equal length of ED and EA, so we have actually one isosceles triangles. So the two base angles are the same, right? So here we have angle 2 as well. And similarly, this angle is also angle 1. Yeah. And now think about the triangle CED. So think about triangle CED. Here, the two unknowns is actually twice of the angle 2 and twice of angle 1. Why? Because they are the external angle, and indeed is external angle, and here we have angle 2, so that's indeed twice of angle 2. So then it's quite easy to find, okay, twice of angle 2 plus angle 1 is the supplementary angle of angle C. So it's 180 minus 70. Yeah, so that means the sum of angle 1 and angle 2 equals to 55. And then in the small triangle, so the angle with question mark, or the angle need to be determined, is also a supplementary angle of angle 1 plus angle 2. So then it's easily to have it. It is 125 degree. Yeah. Okay. Number 4. Number 4 is something like fundamentally complementarics or kind of number theory. No, maybe not so clear, right? And it's said cockroach works along the two-dimensional coordinate system in a spiral way, right? The first question is that how far it should travel till he reached to the point P, the 5, the top right corner. And second question is that if he traveled 2022 units, where would be the location he reached at the end? Yeah. So if we start with simple cases, if we focus on the points on the top right corner, and we say if he want to write the point 1, 1, and he must travel 2 segments, right? 1 and 1, 1 and 1, right? So if he want to reach 2, 2, and he has to travel 4 segments or 6 segments. So 1 plus 1 plus 2 plus 2 plus 3. Why? Because 1, 1. So then here's 2, 2, 3, and 3, right? So if he want to reach 3, 3, so that's again 1 plus 1 plus dot, 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 plus 5 plus 5. Yeah, so here's again 4 plus 4, 5 plus 5. So we can easily find the pattern behind it. If he wants to write n on the top right corner, and that'll be two or twice of this distance is 1 plus 3, 1 plus 2 plus 3 till 2n minus 1. And then we can also use the Gaussian summation to find it as 2 times half of 2n minus 1 times 2n. So we got finally a 2n squared minus 2n. Yeah, so to reach to nn, the distance is 2n bracket square minus 2n. Okay, I'm going to make some space. So the first question is quite easy. You just replace n with 5, right? Because p is 5, 5. So you just replace n with 5, and you can find the distance is like 90. It's like 90 because then it's 10 squared minus 10, right? So here n is 5. So 10 squared minus 10 is 90. 90. Second question is about 2025. And 2025 is famous number, right? Because everybody, I hope everybody, but most of you know 2025 is square of 45. But unfortunately, 2045, 45 is not a even number because here we have the equations 2n. It's all about 2n. 2n is an even number, but 45 is a odd number, right? But fortunately, we have also the identity of square of the sum. Yeah, if we just rewrite it like 44 plus 1, and we know it is equal to 44 squared plus 2 times 44 plus 1, right? And 44 is actually an even number, right? So it's 2 times 22 square plus 2 times 22 plus 1. Just compare our formula with this expression. So we say n is likely close to 22. But of course, here 2025 is larger. It's larger than this equation when n is 22, meaning that we need to go further a little bit. Yeah. So now think about the point here, for example, is nn, right? For the nn. And here we need to travel 2n bracket square minus 2n steps. If it goes down again, further to a point with the coordinate like m minus n. So horizontally it's still n, vertically 2 times n. So he has to travel 2n additional units. Yeah. So then here the total distance becomes 2n squared because the minus 2n is gone because he traveled 2n units more. But then it's still not enough because 2n squared, comparing here, we still need to travel a little bit more. So think about the next step from n minus n to minus n minus n. And the distance between these 2 points is still 2n. It's still 2n. Yeah, so by this we add again. So the total step is 2n squared plus 2n. Yeah. Is this enough? No, not enough because I need to plus twice. We need to plus twice or 2n. So that means we have to go up again to the north to the top left point. That will be n, no, minus n, sorry, minus n plus 1. Yeah, because it goes a little bit above. And it shares the same x-axis. So the distance equals to the difference of the y-axis will give us 2n plus 1. So the intermediate distance is 2n plus 1. And then we add the 2n plus 1 to this number. So we get to reach minus n plus 1 to reach to this point. The distance is 2n squared plus 2n. So that is from here. And we have to plus 2n plus 1. So it gives you 2n squared plus 2 times 2n plus 1. So comparing to the 2025, so comparing to this one, we find n is 22. So that means if Gaspard travels 2025 units, and he will reach to a point on the top left corner, and whereas the coordinate will be minus 22 and 23. So that is minus n and n plus 1. Minus n and n plus 1. Okay. Last question. Something about the symmetry. So the question states that the figure A, figure B, and figure C shows some combination of disk or circles, right, in gray. And each circle is tangent to each other, and the centers of the circles are also tangent to each other on the same horizontal or vertical line. And the question is asking, for each of the case, A, B, and C, is there a non-horizontal, non-vertical line that divide the figure into two parts with equal area? And we have to justify our reasons, right? So that is basically something about the symmetry. If we know already the symmetry, we call it the central symmetry or rotational symmetry of 180 degree. For example, a circle, the rotor center, we call the center of the rotational symmetry as rotor center, is actually the center of the circle. So meaning that if you draw any line through the rotor center, it will always divide the circle into two halves. And two halves are the equal, the congruent, equal area, right? You can draw as many as you will lines, or draw an infinitive number of such lines. So that's the rotor center, right? And if we can combine the two circles, that's also easy. For example, if we draw two circles which are congruent, which are tangent to each other, congruent circles and tangent to each other, and they have also two centers. And in this case, if we just draw, okay, the circle on the left, this is the rotor center for the left circle, this is rotor center for the right. So images say if a line is passing through the both rotor centers, meaning that this line will definitely separate the two circles into halves. That's true. That's true. But the question is asking a non-horizontal, non-vertical line. So we have to find something new, right? We have to find something new. So instead of the centers, we also have so-called tangent points. So the tangent point is actually also a rotor center for the both circles. Yeah, it's just imagine when you rotate these two circles around this center for 180 degrees, it will perfectly overlap the original shape. So that means the blue point, the tangent point, is a center of rotational symmetry. So that means any line through this blue point will divide the shape into two halves. Yeah. So that is a good finding, meaning that okay, for the first drawing, I mean the six circles, the figure A has six circles in two lines, and we can easily find, okay, what will be the tangent point in the center. So we can easily find, okay, there's two rows, three columns, so we can find a center of here. So I'm going to also change to color. So the center of this shape, and there's also a tangent point of the two circles, is a rotor center, or the center of the rotational symmetry. So any line through this center will divide the figure into halves. And these two halves are congruent, meaning that the area will be anyway the same, anyway equal area, right? So that is the answer for figure A is yes, possible. And there are an infinite number of lines like this, okay? Number two. So this one is a little bit more challenging. There's also two rows, meaning that the rotor center must exist somewhere in the middle line. Two rows, but they're not this. the shape is not reflection symmetric in the horizontal way. Yeah, we cannot find the horizontal line, which is a reflection line of symmetric. But similarly, we can also find the center of the four circles here. It's not a tangent, point, but a point in the middle. So this point is also a rotor center of the whole shape. So meaning that if you turn around the shape clockwise or anti-clockwise for 180 degrees, the two shapes will be overlap exactly each other. So this center or this point is the rotor center of the shape, meaning that any line through this rotor center will divide this shape into half, and the two halves are exactly congruent. Yeah, the two halves are exactly congruent. So you can draw as many as you will lines, which meet the condition. Figure C is a little bit challenging, but figure C is very interesting. Yeah. So actually, the 5 circles is not let's say mirror symmetric, or it's not a rotational symmetry, meaning that you can hardly find the points. If you just rotate this shape around this point for 180 degrees, it will overlap the original shape. No, it's not possible, probably. But one thing is that to mention the symmetric or the rotational symmetry is also additional. We can add a rotational symmetry shape to another one. And we can also subtract a rotational symmetry to another one. Yeah. So if we start with the 6 circles, imagine we still have one additional circle here. And then we know the rotor center of this shape is a figure A. It's exactly figure A. So the rotor center is somewhere here. So I'm going to use another color. So the rotor center will be here. Yeah, so that's what we learned from the figure A. But unfortunately, the circle we draw on the bottom left does not exist. So meaning that we have to subtract this circle. And what is the rotor center of this circle? So indeed, that is the center of this circle, right? The center of this circle. So we can subtract this circle from the 6. And we know that the 2 points are the rotor center of 6 circles and 1 circle represent respectively, right? And if any line through these centers will divide the 2 shapes into halves. So if we just connect these 2 points, that means this line is the common line which split the 6 circles into half and split the 1 circle into halves. So in other words, if we change the color, the area of this part is the same as this part because the line through the center of the white circle, right? And with regard to 6 circles, the area of this part, the blue part, is exactly the same as the blue part in the lower part, right? And now the blue part is subtracting the same half of this circle out. So that means is indeed separates these 5 circles into halves, and their area is the same, although they're not congruent. But the area is the same because they subtract the same half of circles out, right? Before the subtraction, you know this area here and here is exactly equals to the green ones. Yeah, exactly the green ones. And after subtraction, the half circle, so the result should be also the same. Yeah, so that is one solution for figure C. That's also possible. We can also do it in another way around. We can do it like an additional way. Yeah? So instead of subtraction, we can also prove it's like addition. So imagine the circle on the top left is something to be added. So we first think about the rotor center of this circle is the middle or the center of this circle. No problem, right? And now think about the rest four. And the rest four is quite symmetric, right? It's quite rotational symmetric. So easily find the rotor center of the four circles is here. It's in also middle. Now we also draw a line. We're going to connect these two rotor centers and make a line like this. Connect these two lines. And it's easy to know, okay, this line is through the rotor center. So actually for the single circle on the top left, the two parts are equal. Yeah, the all half of the circle. And with regard to the four circles on the right, the three parts in blue are also equal because the line is passing the rotor center. So you know the three green cross plus one blue cross is the same as the three green cross and one blue cross below. So that means this line just divide the five circles into two halves. They are not congruent, but the area are exactly the same. Okay, so that is the end for today, the end for the introduction to the five problems for the mini level. So tomorrow we'll work on the midi level. So that will be the paper for the student from the third year and the fourth year. See you tomorrow.